Please, I was asking.
Yeah, but your line is breaking. Oh, I can hardly hear what you are saying.
Please, can you hear me?
Oh shit, the noise associated with it is huge. Please, somebody else should speak for me to see. I just want to test if the problem is with my device. Amma.
Sir, please can you hear?
Oh shit. It's let me reconnect my earpiece, right?
Okay, sir.
Prompting me. Inshira. Oh, Inshira is gone. Inshira is gone. She's going for benediction. Okay. So this does not affect us because gravity is constant on the surface of the earth. But for two different planets, gravity is not the same. So when you go to different planets, then the period of oscillation would also change because J will not be the same. Okay, so all that you need is that, okay, for different acceleration due to gravities, this is the relation to work it out. Just as for different lengths, this is what you have to use. I hope it's clear. I hope it's clear, class.
Yes.
All right. Now, do not also forget that period is also equal to time, total time, divided by the number of complete oscillation cycles. So if T is equal to 2 pi on L over G, because period is also equal to this, I can also equate T over N to 2 pi over L on G. And we use this relation in the lab without doing the experiment. What is usually done is that you will be given the length of a string, varying lengths. Let's zero in on applications of this in the lab a little bit. So in the lab, you are given different values of L. Then find the time, then the period, then they'll also ask for T squared. Something like this. Let me create my own values of L. Starting from 150, 100, 80, 60, 50. Are you there? Are we there?
Yes.
Okay. So what we usually do is that then you will be asked to determine the time using the stopwatch. Using the stopwatch, you are going to determine the time for maybe n is equal to 20 oscillations. So this is how you begin the experiment. You measure starting with 150 from the middle of this ball or of this body to where my hand is. You measure a distance of 150. Then you are going to displace this and then count and time for 20 oscillations. So you, after measuring 150, you displace it and begin counting. A complete oscillation, when you displace it, it must go and come. So 1, 2, 3, 4, 5, say up to 20 times. Whilst you are counting, you need to time, because you need the time for 20 oscillations. So the moment you oscillate it, meaning I'm starting my stopwatch. 1, 2, 3, 20 times. So after the 20 counts, you record the time here. Maybe you had X seconds. Then you measure 100. Go through the same thing. Displace the counts and time for 20 oscillations. 1, 2, 3, 4, just as you did in the 150. Record the time on and on and on. So when you finish, you determine the period. The period is equal to T over N. Total time obtained here divided by the number of oscillations. So total time you obtain here divided by 20 for each one of them. When you finish, T squared is a calculator work. I hope you are okay. Are we okay?
Yes.
Now, in the experiment, when you give me this, I can use this to work the time without actually doing the experiment. So start 1, 2, no, waste of time. This is what I'll do. As I said, period is also equal to T over N. 2 pi times L over G. So this is what I want here. This small t, total time. N is 20. So T over 20 is equal to 2 pi times, I begin with what I'm giving, 150. 150, I must convert it to meters, because I'm going to use J value of 10 meter per second squared. So you change 150 to meter, and that is 1.5 divided by 10. So blah, 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 blah. Then I determine that will be for X. That will be for this value. Isn't it so powerful? Amma,
Mr. Yeah, please. When we substitute the values and we solve, the answer we get will be for which one? Isn't it for
what length am I using? I'm using
1.5?
150. 150. So that will be the time here. Calculate it and let's put it there. You calculate the whole thing. So meaning T here will be equal to 40 pi divided by 0.15, isn't it?
Yes.
So let's calculate.
You say you are using, because you know another way of t, you're using it to find for small t.
Exactly.
Okay.
I'm determining small t. This is total time. Okay. When you finish, you then come to 100.
Yes.
This time 1.5 will change to 1 meter. That's all. So practically you doing this, counting and then timing for the length of 150, I can use the formula to get the time. When I get the time, I can easily find the period, because the period is whatever time I get. Please calculate this one for me. I want to know the t value for 150. And give me your value in 3dp. I get your question, but it will be close to this answer will be close to the practical answer you have. Very, very close, almost just slight difference to that practical when you had actually done it. And you are not wrong. It's a smart way of going around. Anyway, you are coming. When you understand the theory, you know how to go about practicals. So what answer did you get for 150 for T? What have you had for this? This is one thing I don't like about you girls. So calculate this for me, and nobody is ready to call whatever you've had. I'ma go ahead. Go ahead.
50, I got 48.67.
I hate this time wasting. 48 points.
67.
Do it for 100. And let me draw your attention to a trend. Do it for 100. Somebody else should do it for 80. What have you had for 100? What have we had for 100?
That's 9.74 seconds.
Is that you had 49?
39. 39.74.
Yes. 74. What about 80? What about 80?
$35.5.
35 points.
54.
So if you are to determine the period, it is just this divided by 20. 48.67 divided by 20. 39.74 divided by 20. 35.54 divided by 20. And look at this. We just said that the period. Okay, so divide 48.64 by 20 for me. Somebody else must also divide 49.74. Be part of what we are doing. The rest of you don't be just spectators. We want to save time, so be involved in the calculation. Somebody else should divide 39.74 by 20, 35.54 by 20, so that we can save time. What have you had for 48.67?
$2.433.
2.433. Then 39.74.
1.987.
1.987. Then 35.54.
1.777.
All right. So we said that T is directly proportional to square root of L. Meaning, if L is increasing, T must increase. If L is decreasing, T must decrease. Look at our values. When we are going up, is L decreasing or increasing? When we are moving up,
Increase.
is it increasing or decreasing? Increasing. And look at the value of T. T, as we go up, T is also increasing. Then if we are coming down, L is decreasing. And the value of the period is also decreasing. So both period and small t follows the trend. Don't forget, we also have t. If t is directly proportional to square root of L, then small t from here is also directly proportional to square root of L. So when L is increasing, t would also increase. When L is decreasing, t would also decrease. And you see, in practicals, usually we don't even show interest in your values. We don't show interest in your values. These values you have had. We are interested in the trend. And the trend is that as L increases, T must increase and period must also increase. As L decreases, T must decrease and the period must also decrease. So when I'm marking, in practical, when I'm marking, or we are marking, we look at the trend. All that I use to judge what you are doing is this. T is directly proportional to square root of L. So if your L is increasing, then I expect this small t to be also increasing and capital T to also be increasing. I don't need your values. WAEC doesn't use your values. The trend is what we look at. So if you understand the theory so well, you can go around it and then just get your values and then finish it. That's all. So you, as we move on, I'll be pointing out these things to you to apply. Okay, any question? Now, another application in practice. Yes, Amma.
Sir, please, is the decimal this one? The decimal numbers, no, I mean the decimal
Point.
places, are they also important?
They are important. There are ways as we move on, we'll discuss it. Okay, so we are in the business together, so you don't worry.
Okay, sir.
It's more of practical application, so we'll talk about it. Now, another application of this is that in practicals, then after doing this, they will ask you to plot a graph of maybe t squared on the vertical axis against L on the horizontal axis. So this is basically what they are saying. T squared against L if it is this. So after plotting the values you have for T squared, L is this. When you plot, you will have a straight line. Then they ask you to find the slope. Find the slope. The slope is equal to change in T squared over its units divided by change in L over. The question is that, so after doing this, what proves that the value you've had for the slope is correct or wrong? Okay, what is the indication that the value you have for your slope is correct or wrong? You need to understand what this means. Now, from the formula, T is equal to 2 pi times the square root of L over G. I want to manipulate this and have T squared and then over L somewhere. So if I square both sides of the equation, I have T squared equal to 4 pi squared L over G. When I multiply 2 by 1 over L at both sides of the equation, I have T squared over L equal to 4 pi squared over G. Look at this. What is this? Yeah, but what is this part that I've circled? What is this? Yeah, but do you have any idea?
Oh, please.
Okay. Let me draw your attention to it. Share. You see, you were asked to find a slope. Yes.
Is it as a
That's the slope. Okay, that's the slope. Look at it. When I find the slope here, the slope S is equal to change in T squared over change in L. Whether there is a change or not, this is actually T squared over L. So it means that if from the equation, when I make T squared over L, this is the slope. So it means the slope is actually equal to 4 pi squared over g. So when I'm working this out, to be sure whether I'm correct or wrong, I know this is 4 times 3.142 squared divided by gravity, which is 10. So whatever I will get for this must be the value of the slope which you need to have. So usually, because this is practicals, the value of the slope must be equal to 10% plus or minus of this. Determine this for me. 4 times square the power multiplied by 4 divided by 10. And then give me the final result.
3.95.
Yeah, 3.95. 3.95. Okay. So when I'm marking, I will take 10% plus or minus of this value. 10% of this is equal to 0.395. So your accuracy must fall between add 0.395 to this and then subtract 0.395 from this. So plus or minus 10%. So 3.95 plus 0.395. And this, see, this is equal to 4.345, or when I've subtracted this 0.395 from that, 3.95 minus 0.395. And this must also be 3.555. So when I'm marking, this is how I judge your values. Your value of the slope must be either this or this. I have not done the experiment, but I could judge the accuracy of your values using the theory. Please, is that understood? Class, is it understood?
Mr. Adria.
Amma,
Mr. Adria, please. So the slope is a constant. Is it a constant?
what I'm saying is that I can use the theory to find what your slope must be. I can use the theory to determine what your slope would be without actually doing the experiment. That is what I'm saying.
So say for any question they give us, we must either get 4.345 or
No, this
3.555
is
for the
in
slope.
connection with this experiment, pendulum experiment. We are applying the pendulum, simple pendulum.
Yes, please.
So I'm
Yes,
giving
like
you,
for
the theoretical applications within simple pendulum.
oh, okay.
So if mute yourself, if the slope, if you're asked to plot a graph of L against T squared, if you are to plot a graph of L against T squared, then don't forget that your slope, which is equal to change in L over change in T squared, okay, here. When you relate this, okay, let's pick it from here. So your slope in this case, let me mute. And you might mute yourself. Over here, when I determine the slope will be change in L over change in T squared. Now, what is changing L over this? So T squared will be equal to 4 pi squared L over G. This time around, L must be the vertical and G must be the horizontal. So T squared must be the horizontal. So I get rid of, I multiply through by G, divide through by 4 pi. And when I finish, I also divide through by. So this time, my slope is rather equal to G over 4 pi squared. Because L over T squared is the slope here, S. And S this time must be equal to this. So theoretically, it must be equal to 10 meter per second squared divided by 4 times 3.142 pi squared. So that is the theoretical application of the period. Okay. All right. So I think let's go through the theory. Once we've been having online, once you are in Gehe and all that, when it comes to the practicals, I'll teach you the theoretical applications of it. All right. All right. So that's it. Now, one may ask, what is the relevance of the motion of the simple pendulum? Is it important? Or we just displace a body to oscillate in that to and fro manner and just that's it? It has a very important application. How do we apply the motion of a simple pendulum? You see, if you have visited some factories before, factories, because of ventilation, because of brightness, okay, within the working space, factories usually have the floor level to the roof level very, very high. Okay, and that is, they do that deliberately so that air can really blow within, so that heat cannot be concentrated within the working environment. Because, and then church, okay, some churches too. Now, supposing, because of the high level between the floor and then the ceiling, when lights are being mounted, the light is usually suspended. So from the roof level, they use wire to connect the bulb and bring it closer to the working plane where they will be working. Because if that is not done, the brightness or the luminance level of the room will be less because the bulb must be installed at the roof level. And look at the height. Please, I hope you are following the discussion. So for these reasons, they need to suspend the lamps using wires. Now imagine being an engineer and then you being asked to calculate the length of the wire, okay, from the roof level to where the bulb hangs. There is no way you should, as an engineer, you should request for a ladder. Give me a ladder to climb and go and then measure. Oh, the easiest method to use is oscillation. And this bulb thing I'm talking about is also used in some restaurant. In some restaurant too, the bulb is brought and then night claps. The bulb is brought closer to the working plane. So if you are to calculate the length of the wire from where the bulb is to the roof, what you have to do is that, assuming this is the roof level, and the bulb hangs, this is the working plane. Working plane. And in a factory, this is where machines and all the things that has to be installed is. You can't request for a ladder to measure from here to here. No. Waste of learning, and you can apply what we are doing in physics. Let me check. Oh, please hold on. Let me connect. Oh, shit. My speakers are not here. My earpiece has started giving me signals, unfortunately. So what you do here as an engineer is that you hold the bulb and then displace it to oscillate a certain number of times. So time for that number of oscillation. So, and maybe 5, maybe 10. Determine the time for that number of oscillation, T. Now, after determining the time, you are going to use this. This is what you are going to use. By determining T, you decide this, 5, 10. You can calculate for the period. So the period will be T over N. So if maybe you got 20, the period will be 20 over 5. So you have 4 is equal to 2 pi root of L over J is constant 10. So the moment you determine L, you have the length of the wire which connects the bulb to the roof. The moment you determine L from this equation, my speaker, my earpiece is gone. I'm coming. Hello, can you hear me? Class, can you hear me? Oh, I can't hear you.
Yes, please.
I cannot hear anything from you. Okay, so let's even wrap up. So the moment out of this equation, when you square, you have 16, 4 pi squared, L over 10. So L therefore will be equal to 160 divided by 4 pi squared. So whatever you get is the length of the string from the roof to the ball, L. And you have determined this without climbing. Okay, you are applying your oscillation method to determine the length of. So the whole thing, the whole arrangement is similar to a simple pendulum. Yours is to displace it, count the time for a certain number of oscillations, and you are good to go with the length of the string. So that is the application of simple pendulum in the real world. Okay. It's unfortunate I cannot hear from you. I would have given you the chance to ask 1 or 2 questions. But if you have any question, please, you can WhatsApp it to me. All right. I'll also follow suit with your answer and then give you assignment for the week, the weekend, and then the week. All right. So this is why I draw the curtains on our meeting today. Thanks for your time. Thanks for your contribution. Okay. And I'll forward your assignment within the day until 3 to 5 on Monday. Please take very good care of yourselves and then have a lovely weekend. Bye-bye.
Bye.